Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In this series, we are going to learn and implement data structures and algorithms using scalar functional programming approach. Alright, in our previous videos, we learned about what is a dynamic programming, how it is different from divide and conquer, and what are different types of dynamic programming. Now, in this video onwards, we will be implementing examples of dynamic programming. And the very first one is our own Fibonacci series. So what is a Fibonacci series? Fibonacci series, as we see, is a sequence of number. This is a sequence of number where each number, pick any number, say 5, is the sum of two preceding ones, 3 and 2. This is the formula. Pick any number and take the last two and add them up, and there you go. Alright, now let's implement a recursive solution to this. For Fibonacci series, I have implemented the solution in three parts. First one would be recursive, second one would be the memoization, and third one would be the bottom-up approach. So let's implement the recursive one. Alright, so let's write the anonymous or the higher order function. So objective is to get the Fibonacci number for a given value of index. So it will be int to int. So int would be the value that we are going to provide, and then we are going to write n, and it will be of type int, which will return a method that will be if n is equal to 0, return 0, else if n is equal to 1, return 1. Now we are going to recursively calculate the Fibonacci number. So let's give the value n minus 1 plus recursive Fibonacci number n minus 2. Alright, so what's happening here? In every recursive call, we are trailing back again from the beginning. So what does it mean? If I give a value of recursive or the value of n is 6, the output that we expect would be 8. Let's see, 0, 1, 2, 3, 4, 5, 6. So 8. Now how does this happen? So when the value is 8, alright, so it will check. We don't have anything here as of now. So it is going to recursively call n minus 1. So what it is going to call? It is going to call 7 and it is going to call 6. Again, it will go for another loop and it will call 5 and 4. And again, it will go for another loop and it is going to call 3 and 2, and again it will be calling 1 and 0. Alright, so it finds the value 1 and 0. Now it will start adding them up. So once it reaches here, now we know that we have the value. So this is going to be if n is equal to 0 or n is equal to 1, that will reach to the value 0 and 1. Now when it comes to 3 and 2, it is also going to call again 1 and 0 to evaluate 3 and 2. Same as it goes with 5 and 4, it is going to call 3 and 2, and it will also call 1 and 0, and so on. When it reaches 7 and 6, it's going to call everything again. So as we see, as the number of n grows, the more and more recursive call is happening. This can result into a stack overflow or out of memory when the n is very large. So let's see how it performs in terms of time complexity. Let's have a start time, which will be system dot nano time. All right, let's calculate the result. So let's do a recursive Fibonacci series, Fibonacci number, and let's give a value as say 6, and let's do an end time. All right, and let's give it a value as system dot nano time, and let's calculate the difference, which will be end time minus start time. All right, let's print them up, println, and let's see if we are able to calculate the values or get the Fibonacci number for a given index. So let's call the result here. All right, yeah, and let's print the time taken. That would be the dollar difference. Okay, now let's run this and see whether we have achieved as we expect. So the value should be 8, and it should also give the runtime for this. So we see it's 8900 nanoseconds that we have, and it is eventually calculating correctly. Now, as in the next following video, we will be implementing the memoizing technique. We will increase the value of Fibonacci number, and we will see how the runtime is going to change and what would be the impact, and how the memoization technique improvises on the execution, and what is the trade-off in terms of space. All right. If you enjoy this video, please like and subscribe, and see you in the next video. Thank you.